So here we have a linear differential equation, which we are going to use dy over dx plus p of xy is equal to x and y e raised to integral of p of x dx is equal to integral of q of x times e raised to p of x dx to solve for the linear differential equation. So here in number 1, we have y prime plus y cot x is equal to sine 2x. First, let's arrange the equation into dy over dx plus p of x, which is tan x, y is equal to q of x is sine 2x. Then we are going to use y e raised to cot x, cot x. So y e is y e raised to integral of cot x dx is equal to integral of q of x, which is sine 2x, times e raised to the integral of cot x dx. So the integral of cot is cot x dx is trigonometric identity of cos x over sine x dx. Then we are going to let q is equal to sine x, du is cos x, so dx is du over cos x. So cos x over du over cos x cancel. We are left with 1 over u du, which is 1 over u is, remove the integral, so 1 over u is 1 over u is sine, so 1 over sine x. Integral of 1 over u is ln of u plus c, so ln of u is sine x plus c, or just remove the plus c because we won't be needing it. So, yeah. Then y e raised to ln of sine x. ln of sine x is equal to sine 2x times e raised to ln of sine x dx. We can cancel or inverse e and raised to ln, so cancel. So we have y sine x is equal to integral of sine 2x times sine x dx. So to get the integral, we have to use the integral in trigonometric identities of sine squared x is 2 cos x sine x. So therefore we have 2 cos x sine x times sine x. Then we are going to cos x sine x times sine x dx. Okay, we can times sine x, so we'll have sine squared x cos x dx. So we let u is equal to sine x, du is cos x, then dx is du over cos x. Then we'll have is equal to 2 integral of u squared cos x du over cos x. Then we can cancel cos x. We are left with 2 integral of u squared du, and the integral of u squared, we'll use the power rule. We have 2 cube over 3 plus c, or 2/3 u. U is sine squared x. So we'll have that plus, then we have y here, which is y is equal to, wait, y sine x plus c. So to remove, this is cube. So to remove sine x from y, we have to divide it by sine x on both sides of the equation. So we'll get y is equal to 2/3 sine squared x plus c over sine x. And that is it. So for problem number 2, okay, so just copy this. This have the condition of y is equal to -0, is equal to -2, and x is 0. Y of 0 is equal to -2. So here we'll arrange the equation. So dy dx plus tan x y is equal to sine 2x. So it's just like the same from the other equation, so let's use the integrating factor of y e raised to integral of tan x dx. So, and then integral of q of x is sine 2x times e raised to tan x dx. So tan x, integral of tan x dx is, trigonometric identity is sine x over cos x dx. Then we are going to let u is cos x, du is negative sine x, then dx is du over negative sine x. Sine x over u, du over negative sine x. Cancel sine x, we are left with negative, so negative 1 over u plus c. So the integral of 1 over u is ln of u plus c. Negative ln of u plus c. So negative ln u is cos x plus c. And in the trigonometric identity, negative ln is, wait, so that's the answer. So we're going to substitute negative ln of x here. So ye raised to negative ln of x, ln of cos x, so is equal to sine 2x e raised to ln, negative ln of cos x. Then we are going to cancel or inverse e raised to ln x, so it will be left with y arc cos then sine 2x, so arc cos x dx. And we know that arc cos x is the trigonometric identity of secant x. This is 1 over cos, so cos x, so it's like secant x. So the identity is secant x. So we have y secant x. Secant x is equal to sine 2x secant x dx. Then we are going to use another trig identity, which is sine 2x is equal to 2 cos x sine x. Then we have, let's take out 2, we'll have sine x cos x, we'll have, let's first cos x sine x, then secant is 1 over cos x, so let's use that. Cos x dx. Then we are going to combine 1 times cos x sine x over cos x. Then we are able to cancel cos x. Then we'll be left with 2. 1 times sine is sine, so we'll be left with sine x. We'll have y sec x is equal to 2 integral of sine x dx. Integral of sine is negative, so we'll have y sec x is equal to 2 negative 2 cos x, then plus c. So we have to further simplify y, so we divide both sides by secant x, then secant x, get y is equal to negative 2 cos x over secant x plus c over secant x. And we have the condition of y of 0 is equal to negative 2. Then we substitute y to negative 2 is equal to negative 2 cos x is 0 over secant x is 0 plus c over secant 0. Then negative 2 is equal to negative 2 cos of 0 is 1, so 1 over secant of 0 is 1, and plus c of 1. Then we get negative 2. Negative 2 times 1 is negative, over 1 is still negative 2, plus c over 1 is c. Then we transfer negative 2 to the other side, so we'll get negative 2 plus 2 is equal to c, and that results to 0 is equal to c. So here in our solution, equation, we get y is equal to negative 2 cos x over secant x plus 0 over secant x is still 0, is equal to 0. So don't need to put the 0 here. And that is it for the particular solution.